Hey y'all, welcome to Miss Clarke's chemistry class. We're going to continue talking about electron configurations. Remember, the periodic table, it's nothing but patterns, lots and lots of patterns. We've already talked about the valence electron pattern. The periodic table also shows us electron configurations. We're going to learn how to use the periodic table so we don't have to have Aufbau's principle memorized. So if we want to identify this specific trend on the periodic table, the S sublevel has one orbital, so it holds 2 electrons. Look at this right here. 1 group, 2 groups. We call this the S block. Every element in these 2 groups are going to be in the S sublevel. Next is the P sublevel, which holds 6 electrons. 1, 2, 3, 4, 5, 6. These other groups, since there's 6 groups, lines up perfectly with 6 electrons. That's called the P block. These transition metals, if we were to count all those little short groups, there's 10 of them. 10 groups, 10 electrons. This is the D block. And yes, you got it right. Those last 2 at the bottom, there's 14 little groups there. 14, that's the F block. The periodic table is designed to fit this quantum mechanical model perfectly. It's almost like magic. The periodic table is set up in the exact order of Aufbau's principle. If we look at the first element, hydrogen, 1 electron would go in that first orbital. Hydrogen is 1s1. And then if we go horizontally over to helium, 1s2. Helium has 2 electrons, and there they are. And then if we go back over to the left, we get 2s1, 2s2. And if we remember from Aufbau's principle, we go next to 2p. And look how all of those p's fit perfectly. Boron is 2p1, carbon is 2p2, all the way over to neon, which is 2p6. This periodic table is missing something, the period numbers. Remember, groups go up and down, periods go side to side. So if we add the period numbers in, are we noticing something? The periods correlate to the energy levels. Because remember, the big coefficient in front, that's the energy level. Then the letter, that tells us the sublevel, and then the superscript tells us how many electrons. Now, I don't think we need to fill in the whole periodic table, but can we see that everything in group 1 is going to only have 1 electron in S1, and the energy level is going to correlate with the period. The same thing with P, because S and P are both representative groups. They're tall. They represent all 7 energy levels. D and P are a tiny bit tricky, so we do need to spend a little bit of time talking about that before we're done. We went from 4s to 3d. When we talk about the D block, the energy level is dipping down a level. If we're on the 4th period, this is 3d, 4d, 5d, 6d. Because D holds 10 electrons, it has more energy, so it's always a level down. If we're on energy level 4, that's 3D. F block is going to be 2 levels down. Now that we're looking at a periodic table with all of the orbitals filled in and all of the electrons placed, you can see that every element on the periodic table has their ending notation, starting with 1s1 all the way to 5f14. When we get done with learning this trend, you're going to be able to just pinpoint any element's ending notation. Let's look at a few examples. Let's look at silver. Silver is number 47. So let's find silver on the periodic table. Here it is. If we were going to use this shortcut with the periodic table, we see that silver is in period 5. That means 5 is going to be the biggest shell. So this is 5s1, 5s2. But remember, the D block goes down a level. This is 3D, this is 4D. Silver lands in 4D, 1, 2, 3, 4, 5, 6, 7, 8, 9. The ending notation for silver would be 4D9. Like I said, often that's what you're asked for. If not, you could just start. We've got 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 10, 4p6, 5s2, 4d, 9. This is how we can use the periodic table to figure out not only electron configuration, the full format, or just the ending notation. Let's look at one more ending notation. Let's look at something in the F block. We have not tried anything in the F block. We've got samarium, number 62, down here in the F block. So if the D block only goes down by 1, the F block goes down by 2. So if we find SM here, this is going to be 4F 1, 2, 3, 4, 5. The ending notation for samarium is 4f5. So let's circle back for a second. For example, in energy level 3, we said there was 18 electrons. But to have a full valence shell, you only need 8 electrons. And that's because the valence electrons always come from the S and P level. S and P is always on level with the period number. D and F always down 1 level or 2 levels. So anytime you have electrons from the D and the F, it's always from the lower energy level, and the S and P is always from the highest energy level. So whether you need to do the full electron configuration, or whether you just need that ending notation, or maybe you just need to figure out valence electrons, now you know an easy shortcut. I hope that helps. I am here for your success, and the only way I can do that is if you press the like button, and if you subscribe, leave me a comment. Until next time, bye y'all.